Let's think about the impact that gravity has on the velocity in a pipe. Consider a pipe that is tilted downward at some angle so that fluid is flowing downhill. Let's assume that the pipe has a constant diameter and that the fluid is incompressible, or has a constant density. Let's use the principle of mass conservation to determine how the velocity changes from the inlet to the exit of the pipe. Because we know that for a steady-state process, mass must be conserved, the mass flow rate must be constant. Therefore, because we have an incompressible fluid, the volumetric flow rate must also be constant. We can express the volumetric flow rate as the product of velocity and cross-sectional area of the pipe to give a relationship between the velocity at the pipe inlet and exit. From this equation, we can see that even though the fluid is flowing downhill, the velocity must be constant in the pipe because the pipe has a constant area. Therefore, gravity does not affect velocity in our DLM. Let's consider how gravity does affect the flow in the pipe. Let's address this with an energy balance. Since we have a non-reactive, steady-state process, the total energy change in the pipe must be zero. We can express the total change in energy as the sum of potential and kinetic energy changes, flow work, and frictional losses. We know that kinetic energy changes are zero since the velocity is constant. We can express the change in flow work as the pressure change divided by the fluid density, and the change in potential energy as a gravitational constant multiplied by the change in height. For a non-tilted pipe, the pressure change is simply proportional to the frictional losses in the pipe. However, since we now have an added term in our energy balance due to potential energy changes, the pressure loss must change to account for this, since the frictional losses remain the same. For a downward tilted pipe, the change in potential energy is negative, since the initial height is higher than the final height. This means that the pressure loss in the pipe must be smaller than it would be for a non-tilted pipe, so that energy is conserved. In summary, gravity does not affect the velocity in a pipe, but it does affect the head losses observed in the pipe. Here are some thought exercises for you to consider. Would the pressure losses in a pipe tilted upward be smaller or larger than for a level pipe? As an engineer, what are some possible implications of your answer?